hello and hello. Welcome to John Park's Workshop. It's me, John Park, and I am back after a week off. Thank you for tuning in. We've got a really great show lined up for you today. And by we, I mean me. I mean, I've got a great show lined up for you today. I promise. I wouldn't lie. So we have some significant heat, again, still here in Southern California. So I'm going to have the shop door closed and the AC on today. Hopefully that isn't too distracting to hear the fan back there. I've also got the fan pointed at my camera so that it doesn't overheat. So I think we're ready. We're ready to do this. So before we go any further, let's start off with the coupon of the day, of the week, of the show, of the episode. This is it. Edvard. E-D-V-A-R-D, and that will get you 10% off in the Adafruit store on everything you can imagine other than gift certificates, subscriptions, and software. Thank you. C. Grover just checked in to the chat and told me that the fan noise isn't so bad, so that's good. I'm going to try to stay hydrated. So let's see. Yes, 10% off in the store today. Expires at midnight tonight. Maybe Eastern Standard Time, maybe Pacific. I'm never quite sure, but probably Eastern. A lot of Adafruit stuff is running on Eastern. So 10% off will get you in the store with Edvard as your coupon code. So enter that. All right. Now, since we've got our, let me pop over to the chat here in YouTube as well, just to make sure. Hi, everybody. Hello, Tiny LED Matrix and Clash King 11 and Matambale and Kinger North and Matambale again. And over in our Discord chat, if you haven't gone and checked out the Discord for Adafruit, it's a great place. It's kind of always hopping. It's 24-hour-a-day hangout for Adafruit people, so go check it out. We have a bunch of different channels, including the live chat channel, and that's where most people are hanging out right now, I think. But we have channels for CircuitPython, we have channels for project help, for general discussion, what else? Pet photos, off topic, all kinds of things. So please check out the Discord. And if you need instructions on getting onto our Discord, we have info up on the blog. If you go to the blog post for this here show, so blog.adafruit.com, you will see a link to our Discord, so go check it out. Hey, Yenny Scoo. Welcome. Hey, Mr. Certainly. Okay, so now this brings us to product of the week. So the product of the week for this week that I selected is one of these lovelies, the LED neopixel quarter ring. So that's 1/4 of a circle. And when you combine a whole bunch of these, let me see, I have a couple loose ones. Here's one other loose one. When you combine these, you solder them together on the back side. And you can, let me switch the image right here. You can make a ring of 60 neopixels. I have used these before in a project. If you remember this guy right here, this is my Overwatch blaster that I built. And if I turn it on here, it's going to make noise too, but if you watch the front, it's going to light up. If I put that closer, maybe I can trick it into showing you some color. It's a lot out of focus. I'm going to switch over to green mode. There you go. Yeah, green's a little easier to see there. And when I shoot, it gets brighter. So these neopixel rings, you can get them in RGB, RGBW cool, RGBW neutral, and RGBW warm, I think. This is the cool one, I think, right here. And they're either $10 or $12 depending on RGB or RGBW. That's got the fourth diode in there for the white. And that is PID 2875. So you can go to adafruit.com/product/2875. And I'm actually going to also, let me show you one I've got here. So ignore for a moment everything else, but there's a ring, and I'm actually going to use that today in the Make Code Minute. So there's a ring without a diffuser on it at the moment, with 4 of those segments soldered together. You can just bridge solder across them, by the way, or sometimes what I like to do, not that way. Hello? There we go. That way. What I like to do is take little leads that I've snipped off of other components like a resistor or a regular LED and solder the connection with 3 of those little leads across the solder pads just to give it a little bit of extra mechanical strength if you're not planning to hot glue them to something or embed them otherwise. So very cool LED ring, and I haven't done a product of the week in a while that's an LED or a neopixel thing, I don't think. So, and it's going to figure into our Make Code Minute. So I wanted to remind everyone about those lovely Gigantor rings. Yeah, watch where you point those things, right? This is a giant blaster. I've actually got neopixel rings all over the place and strips and stuff, but I think that front one is a very cool use of these giant 60 pixel rings. And I've seen some clock projects, I think, with them. You can do a lot of neat stuff with the LED ring that size. All right, so why don't we move on to the Make Code Minute. Yeah, all right, so for our Make Code Minute today, let me bring up my overlay window here. Great, okay, so what I want to do today in the Make Code Minute is show you how to connect and address external neopixel rings from either a Circuit Playground Express or a Cricut when you're using Make Code. So inside of Make Code, let me switch over here for a second. When you have the extension Cricut enabled, which I do here, there we go, let me move some stuff out of the way because that's cheating. You can go up to, let's go to, oh, you know what, do I lie? You might not even need, yeah, I just lied. All right, let me start that over again. We don't even need to use the Cricut stuff here because actually the only Cricut thing for NeoPixel is the one onboard NeoPixel that's usually used to talk, to show you the status of the Seesaw chip on the Cricut. So for our Make Code Minute today, what we're going to do is take a look at the NeoPixel subheading of the light category. So if I click on NeoPixel here, we have a set strip block that we're going to grab, and I'm placing that inside of a onStart loop. So let's move this up here. So what I'm going to do when I start up is I'm going to set a strip to be on the A1 pad. So you could connect this normally, you could connect this to the A1 pad on just a Circuit Playground Express. But we have this terminal block on the Cricut, which is also connected to A1, as well as the voltage regulator on board the Cricut that gives us 5 volts instead of 3 volts. And the data level is shifted to work on the 5 volts, not the 3 volts. So this is a great way to work with external NeoPixel strips. So with this set strip to create strip here, what I'll do is click the plus sign, and you could pick which of the Circuit Playground Express ports you're connected to. So I'll leave that at A1. And if you click the plus sign a second time, this is a pretty nifty block, it has a lot going on, you can tell it how many pixels are on your strip. So I'm going to say 60. And that will start the initialization of the strip. The next thing I'm going to do is head again to NeoPixel, and I'm going to set this to be, let's see, where is the strip mode? I want to set the strip mode to be RGBW. I think it's down at the bottom. Here it is. So the very last block. If I throw this in on start, we can set this same strip, and you could name multiple strips, I suppose, but we're just going to go with the default here. And we're going to set that mode to RGBW. Some older strips will be RGB as the order that they're addressed. most of your typical NeoPixel strips are GRB, and then we have this RGB plus white, RGBW. So that will initialize the strip, and then we can pretty much use any of the NeoPixel blocks at this point. So we could just set the color of them, we could address individual NeoPixels. What I'll do is just grab an animation block. So this is actually all we're going to need is just these two loops on start and forever. And then in the forever block, what we'll do is for every tick of the clock, the internal clock on the Circuit Playground Express, it's going to play a frame of animation. So I'm going to use this comet animation, and let's go ahead and also run that same comet animation on the onboard NeoPixel ring that's on the Circuit Playground Express. So I'll grab a show frame of animation. Let's pick the same animation, okay? And then I can hit download and drag this over to the board. I've already done that, so I'm just gonna show you. Okay, we've got that animation playing on the Circuit Playground Express, and now what I'm gonna do is turn on the Cricut, and you'll see my external ring also running that animation. Now if I get that closer, you can see the color's a little better. And I also happen to have a spare 3D printed diffuser ring that I made when I was working on my Lucio blaster. Save everything. So I'm going to place that over here. And now you can see with some lovely diffusion, you can see the animation a little better. And so that is using external NeoPixel rings or strips with your Circuit Playground Express and Cricut. And that's the MakeCode Minute. I hope you enjoyed that. So, portable spaceship was born. Yes. Hey, True Tech. Welcome to the chat. Yes, Mr. Certainly is a good point. LEDs and live cameras equals overexposure. I'm kind of curious how that looks on this other camera. Let me switch cameras for a second, and can I drag this over far enough? I'm just going to see if this will reach first. I have a very long USB cable here. Yeah, that'll reach. Oh, this looks pretty cool. Let me switch camera view for you for a second here. Go to the main cam. It's a little better, not as overexposed actually. Kind of what it looks like in real life. And as is the case, you can usually see the reflections of NeoPixels, kind of helps. Wow. I kind of like this animation. I've never looked at it closely before, but it has this nice little bounce. Whoop. And you also notice the order is actually opposite, I think, between the onboard NeoPixels and this ring. I think the clockwise versus counterclockwise. You'll notice that when they do the little bounce, they're going to bounce in opposite directions. Kind of cool. All right, I'm going to turn that off and stop playing around with that. And let's see, what's next? So I think this will take us right into our project build. So let me get this out of the way here. And let's head over to there and there. So if you watched the show and tell on Adafruit last night, you'll have seen my sneak preview of what we're going to be building today, and that is going to be an interactive version of Edvard Munch's The Scream. And it's going to use a Circuit Playground Express with a Cricut, a little speaker, whoa, my AC is blowing things around, a battery pack for power, and we're going to use a micro servo in order to rotate the head of the face in the Scream. And this was actually a self-portrait. It's an interesting story if you go and read the Wikipedia like I did yesterday to learn myself up on the Scream. The painting was a self-portrait that Edvard Munch made about his sort of sense of, he felt like nature was screaming at him. He was an interesting guy and wore his emotions on his sleeve and painted them. So what we're going to do is, first of all, let me switch to a large overhead. How about that one? And I'm going to zoom in a bit here. And what we'll do is we'll take one copy. What I've done is I've gone and, if you go to Wikipedia, you can download a very nice high-resolution copy of this painting. And I printed it out, and I'm going to be writing a guide for this, and I'll be including that link there since it's in the public domain. And so what we'll do first is cut out the head just using an X-Acto, or you could use some scissors, because we only need the head from one copy, and then a regular, we'll poke a hole in this second copy, but we're not using just a single copy of it. So let me find an X-Acto knife here. Oh, and while I'm at it, let me turn on the chat over here on the iPad so that I don't miss any good, important info. All right, let's turn the volume down before. And good. Hey, there we go. Oh, how do I split the screen again? Now it's not working. There we go. Well, that didn't work. Sorry about that. What's going on here? Oh, now they're side by side. Where did the chat go? Here we are. Thanks for bearing with. This is the issue with one man banding it. Good. All right, now we have it all laid out. Good. So let's actually go to this overhead here. And all right, we can zoom in kind of close. Oh, I reversed it again, sorry. I was trying to autofocus. There we go. All right, so all we're going to do is make a isolated head so that we'll be able to place one head slightly in front of the full painting and attach it to a micro servo so that it can rotate. This was, by the way, inspired by PT, Mr. Lady Ada, and Lady Ada were experimenting early on with the Cricut as it was being developed and did a Starry Starry Night painting, which Dana Wall then turned into a guide with rotating stars and moon and swirly clouds. So this was the next one on the list, was to do the screen. Okay, so now we'll take that head and set it aside for a moment. Try to get it not to blow away. And then what I'm going to do is just take a piece of cardstock. I've got some black cardstock here. And I'm just going to cut out a head here that I can use to mount the one that we just cut out. And what I'll do, just so you can see what I'm doing here, I'm going to grab a silver marker and use the cutout to outline what I'll be cutting out of the black cardstock. You could use thin chipboard for this just as easily. All right, now that one will probably just get blown away by my AC. Oh, you know what? Let me just turn down that fan one notch. Excuse me. And let's see. Oh, that's not it. Speed. There we go. Low speed ought to do it. That's not quite as noisy either. Okay, so now what we'll do is just cut this one out. You don't have to be super precise with it. You could trim it later once you glue down the head cutout, or you could make this a little small as you're cutting it. Okay, there we go. Now what I'll do is just take some glue stick, prep that, and lay down our head from the painting, like so. Okay, so now what's going to happen is the head here is going to get mounted on the back side on this piece of cardstock to a servo horn. So you could take a little micro servo horn like this, and let me grab a micro servo. Okay, so this will be on the back side of the painting through a piece of cardboard, and then this will be through a hole coming out to the front with this mounted on like so. So there's a couple ways you can do this. I think what I'll do is just hot glue the servo horn to the head like this, then later we'll center the servo spline and then place it on. You could also adjust this in software because we're not going a full 180 degrees. So, whoops. By the way, if you are following my Instagram or Twitter, I posted earlier today that I stabilized my hot glue gun, the base of it, with a little piece of Sugru. I had some left over from a mug handle repair, and that keeps my hot glue gun from wobbling around when I set it down. So it's a constant problem, these hot glue guns, getting them to sit still. So just a little dab, that's probably too much, will do. And I'm going to place the attachment point, if I can still slide it. Oh boy, this is cooling fast. All right. Yeah, it's a little high. Let's see, will it? Oh, it's on there. All right. Well, I was going to say, I was going to place the attachment point sort of at the base of the skull, but I did that with the other one. We might switch to that one. But if you want, you can set your axle down at the base of the skull where a head actually rotates when you're turning like that. But it's meant to be kind of weird and surreal, so it doesn't have to actually be anatomically accurate. So that's going to go on here like this, and now we'll be able to turn the head using our servo, or micro servo. So now, let's switch over to this one. Next step will be, let's prepare our Circuit Playground Express and Cricut so that we can then move forward with the build. So what I've done, actually this one's ready to go. So I've got a speaker on here. We're going to be using, zoom this down a little bit. We're going to be using a sketch that I wrote in CircuitPython to check the microphone that's built on board on the Circuit Playground Express. Actually, let's swap these camera views. So we're going to be using a sketch that's checking the microphone level, and when that gets above a certain threshold, it's then going to trigger two things. It's going to play a wave file that I put on here that's a mix of some open source screams I found on freesound.org. It's going to play that over the little speaker, and it's while that's playing, it's going to wiggle this servo back and forth. So let's fire this up and take a look. Okay, I'm going to have to yell at it. I think it's... now, calibration might be off because of the AC, which I didn't have before. Let's see. I'm going to just scream at it. Hey! Hey! Sorry, everyone. I'll be yelling yelling into the mic for this. Hey! There we go. Hey! Hey! Oh, you know what? Is this not the one? Because I'm not hearing the wave file play. So let's... oh, I think that is the one. What's going on with this? Who knows what software I have running on there? Let's restart that. Your Siri activated? Sorry, TrueTech. Sorry, Siri. Oh, it tried playing. What's going on? All right, let's look at the code. This is a good moment to switch over there. What I got going on? Matambale, you are awake now. All right. So let me unplug USB from my little LED ring that I had running before. And one of the nice things, I've mentioned this before, one thing I really like about CircuitPython is that you can just when you plug it in, CircuitPython Express or any of our Express boards, you can download whatever code is running on it and see what's going on. So let me, I'm going to launch Moo, and then I'll give you a screen share of that as I load up the code that's running on that. So let's add... You may lose my audio for a second as this screen capture gets added, so 1 second. And... okay, yes, looks like I still have audio, so I'm gonna... Ah, sorry about that. Oh, that's weird. So it dropped the level. All right. Thank you for everyone who caught that. Excellent. My alert is going off now too. Thank you for whoever gave me the warning. Looks like we're back in business. So what's this? Ah. Okay, I'm back now. Thank you. Yeah, when I add a window, it dropped the audio level, even though I had reselected my source. Okay, so this is the code that I just loaded off of the board. So I can tell you what's going on here. So I'm importing a number of libraries that are going to be used for time, so I can pause. Math and array are used for the sampling that we're doing. Some of the code there is used for the sampling of the microphone to get a level. Audio bus I/O is used to read the microphone. Audio I/O is used to play back the wave file. The board is the CircuitPython Express itself, and then I'm importing Cricket, so that I get much of those helper functions. We have a variable here for the number of samples that we're going to check to get a level from. We have a little procedure used to normalize the samples into sort of like an average, or the mean is used here. Microphone is instantiated. We record samples from the microphone. And then I'm also setting up a servo object so that I can move the servo. And then this is the code here that plays back my wave file. And you can see here that the play file wave, and then later I'll tell it which wave file name to use, and that's a wave file I've put on the Circuit Playground Express. While that's running, while it plays, it does whatever is after this while statement, and that is essentially jiggling the servo to 60 and 120 with a little tiny delay, a hundredth of a second delay, so it's just shaking back and forth like that. And this is the main loop here. So I record the number of samples, so 160 samples, and then I use those previous procedures to find out the magnitude of that sound level. And yeah, I'm looking over in the chat in YouTube, TrueTech, this is Circuit Python is what I'm running here. So this is Python code that's running on the board. And then just for me to look at, and I can show you this, at the types of levels we're getting. And in fact, there's also a chance it was acting weird just because of my batteries being low. So I'm going to plug in a 2 amp 5 volt wall adapter. And let's see. Yes, that looks good. I'm going to restart the board. Oh, it's making noise now. All right. So let's turn on, oh, before I do that, so what else is happening? If the magnitude is less than 1,000, so that's the level we'll check in a second to see when it peaks, you'll find that comfortable level for wherever you're using it when you hang this on the wall. Set it and then mostly forget it, or you could set up the buttons on the Circuit Playground Express to adjust those if you needed to. And then what happens when the magnitude is greater than, in this case, 1,000, is whatever happens here in this else statement. So I'm printing to myself in the serial port the word loud, and then we're going to wiggle the head a couple times and then play the play file, which plays the audio file and continues to wiggle the head. And then I'm going to set the head back to 90 degrees, which is the straight up and down position. And then I'll sleep a couple of seconds just so that we don't get caught in a loop of either someone just constantly screaming at the thing or it hearing itself, which I haven't had a problem with it doing. So let's look at, if I connect to the serial port here. Oh, you know what? I'm gonna unplug my little camera button box because it grabbed that one in the REPL. And now if I open up the plotter, let's restart this board. Let's see. We should be, am I not printing right now? I am. All right, what's going on? Let me reload. There we go. I had to hit Control D to reload. So now we're seeing the magnitude levels go by. I just snapped my finger over it, and you can see it grabbed a 15705, so way over 1,000. But normally with me talking here, it's in the 300s or so. Now, if I click plotter, it's actually a bit easier, I think, in some cases to get a feeling for the values. So you can hear when I said values, it peaked at probably around 800 and something, but it didn't cross that 1,000 threshold. And there's the room noise just with my AC. And now what I'm going to do is I'm going to snap my fingers and watch the graph. There it goes. So the graph is going to, it stops since I'm using that time sleep. So it kind of pauses. And you can see it reached over probably around 6,000 or so. And you can see the graph kind of recalibrating itself there. So the graph here, whoa, I said that loud enough that I got its attention. The graph here is really useful for getting set up and calibrating things. So what I'll do is set this maybe at around 1,500. because I think I'm getting some false reads. So where to go? I've lost it. There it is. So this 1,000, I'm going to set that, say, to 1,500. And now I'm just going to save, and it's going to save directly onto the board. And now, good. So now I can say words a little louder and not, ooh, that one, yeah, that didn't get over my 1,500, but almost. Now I'm going to yell at the Circuit Playground Express. So let me hold it up for you to see. Hey! Okay, so I'm noticing, by the way, in video, at least on my playback, the head is moving faster than the frame rate that I'm getting. This camera's being a little slow, so it doesn't look like it's moving that much. So let me snap my fingers and we'll do it again. There we go. A meow sensor to open and close and unlock doors for cats. That would be awesome. Yeah, I think sound activated stuff is fascinating. It's a pretty cool interface. Definitely teach your dog to not bark or something like that at the front door. I don't know. So everything seems to be working now. I suspect what was going on before may have been batteries. So I'll get some fresh batteries, and then let's move over to the workbench, and we will start to build this into the painting. So the question, Mr. Certainly, so do we lose half of the lines of code every time you snap your finger, Thanos? Very good. Yes. All right, little Marvel Universe jokes there. Okay, so let me turn this off and unplug. But you can see how quick and easy it is to adjust your code using Circuit Python. In Moo, that whole setup is just super fast. It's so interactive. I love it. So let's go back over to this camera for a second. Oh, I got to replug in my camera switcher. I'm not actually sure how to have Moo deal with multiple Circuit Playground Express or other Express boards being plugged in when you go try saving or loading. I can just unplug it. All right, so let's see if it works over here with this battery pack plugged in, and if not, I'll get some fresh batteries. All right, that worked just well enough. Oh, that was a little loud. Okay, so now what we're going to do, we're going to get into some of the fabrication of this thing. So I'm going to go to, how about that view there? And now I will take a frame, zoom out here, and I happened to just have a frame that worked pretty well for this. It's a largish frame, but it had a mat for a sort of 8 by 10, and I printed this just on a laser printer, color laser printer. So this mat is perfect for what we're going to do here, and it'll give us a little bit of space. So what I want to do is adhere the painting to a piece of chipboard. You could use corrugated cardboard for this. I might actually stack some chipboard and then corrugated cardboard. What I've noticed is if you glue down your art to corrugated cardboard, you kind of see the lines of the corrugation in there. So I'm going to just take this chipboard and use it to smooth things out a bit. So let's grab a ruler and make a nice, let's see, this fan is messing with me. All right, so line there. I'll grab this. Where is either my X-Acto, which I just had, or a box cutter? There's one. And I don't want to lose the chat. Come back. There you are. set that aside, and we can shorten this up now. Now, one of the issues we're going to come up with is, that we'll have to deal with, I'm not sure exactly how we're going to do it, is creating a bit of a standoff from the frame so that the electronics, which are going to be on the back, don't push into the wall. We want to give them a little bit of offset. So we'll take our glue stick now. It's fun to be using glue sticks for their intended purpose, since if you're like me, you've spent a lot of years using them for 3D printer beds and adhering prints to glass printer beds. But look, it's good for paper. Did you know? Okay. Now we'll set that like so. And I think, you know, it might be interesting to hit this with a finish, like you could use some Mod Podge or acrylic medium, like a matte medium, to give it some texture so that it looks like real brush strokes. Some good techniques you can use for making printouts look more like a real painting. Okay, so that, it kind of gets rid of that sheen that you can see there to give it a texture. So that's pretty good. Work out some bubbles here. Okay, and we'll let that sort of continue to dry now. What I want to do next is cut out a piece of corrugated cardboard that's the size of my frame mat. So that'll be kind of the load-bearing part of the whole operation. So essentially what I need is a piece of corrugated cardboard that fits this, which is essentially the same dimension as this mat. So what I'm going to do is just trace that onto corrugated cardboard. Oh, you know what? In fact, in the interest of time, I'm going to use the one that came with the frame. So the frame just had a piece of corrugated cardboard to use as the backing. So I'm just going to reuse that. It's actually a kind of a nice 5-ply, 3-face, 2-flute corrugation. Can you see that? Maybe, yeah. So that's a nice thick piece of cardboard. That'll work well for us. So that's a shortcut taken. So now what we want to do is we're going to align these things like so. And then I think I'm just going to tape my painting down for now. And I'm going to line up some holes for our servo to protrude through. So that looks pretty good like that. So let me take that. And I'm just going to use some regular Scotch tape, in fact. You don't need archival tape for this. It's the one case. And this will just give me some flexibility here for a second in being able to get through and poke holes and align things without sort of sticking all of that together. So let's take our servo-mounted head, and I'm going to use it to determine. Let me go switch over to the little down shooter for a second. Let's move that into place like this. Okay, so from the down shooter here, let's refocus. Looks good. So what I want to do now is just determine where that hole should be. And on the back side of there where we have the servo horn, I can just press down, and I'm going to leave a little bit of a depression that I can see, maybe. Let's try that again. Okay, so now I see a circle there that you might be able to catch in the glare on his nose. So what I'm going to do is simply poke through that. And when I lift that up, you'll see now I've got that little hole and that little hole there. So that's where I want to cut it out wide enough for this to fit through. So I can use, I might end up just using the X-Acto, but you can use any kind of sharp, pokey thing to make that hole a little bigger to start. Sorry, screaming guy. Sorry, Monk. Okay, so we've started to bore that out a bit, and now let me pull this off by itself. So for just this section, I'm going to just bore that out with my X-Acto. And then push all that junk back through and trim it on the back side. Okay, so let's see if that almost, I might try just reaming it with this tool a little bit more. Almost there. You know what? In fact, I want to see, I've never tried this, but let me see if my little T-handled reamer will help us. It might be sharp enough. Yeah, that fits well. Okay. So that's on there pretty nicely. And now we want to extend that to the cardboard here. I'm also going to get rid of this fuzz here because I want it to lay flat. So let's cut that. I wish this X-Acto blade were fresh because it would do a better job. But I think I'll spare you a blade change in the interest of time. Okay, so now let's bring this back here. We want to mount our micro servo. So this is the one that I just had connected up to the Cricut. And actually what I'm going to do is center it. So just plug it in, give it power. And when I turn it on, one of the first things that was happening is it was going to 90. Okay, it's also the last thing it does after a scream. So now I know it's at 90. 90 degrees, which is how we'll center it properly onto this back here. So now what we need to do is find a way to attach that through there and mount this so it doesn't wiggle around. So you'll see on the end of the servo there's kind of this pear shape. So we want to use that to kind of key this in here. So what I'll do is press it in like this. So with that straight up and down and this straight up and down, we know we've got our 90 degrees, which is good. And then I'm going to trace, just make a little mark with a pencil, this little keyed bit so that I know, you can see that there, what to cut. And we may also have to build up a little bit of a support. All right, that can be vaguely like that. We want to build up a little bit of a support for this as well, just with some hot glue and cardboard, I think. So I'm gonna make some marks on this just so I can, if my tape fails, I can get this aligned again. Okay, that'll do. So let's lift that. Oh, that's staying. Okay. So now what we'll do is I'm going to cut that out. I'll grab my cutting mat and set it underneath here. And you can make this a little shy of inside the line because the pencil mark is a little wide. I was forgetting this is 5-ply and this blade isn't super sharp at the moment, so it's, I don't think I went all the way through. Yeah, look at that, I'm making a hash of that. Let's see what the other side looks like. Yeah, look, barely made it through. All right. You'd think I'd just break down by now and change the blade. But no! We're going to get by with this dangerous dull blade. Get my other hand out of the way. All right, that'll do. Okay, so now you'll see this servo will set in there. And we'll probably just hot glue that so that it doesn't wiggle, but we've got a decent fit there. And let's see, does this protrude far enough? It does. So now I've got that connected to that, and it'll turn. If I move the servo the little bit that I can, you can see that it can wiggle. So in fact, before we go further, I'm just going to plug that in and make sure that it moves. So the last thing you want to do is start gluing things down and find out that it won't wiggle. So I've turned the Cricut back on. Yeah, there we go. A-okay. So let me turn this off. And we'll continue with the mounting. So it looks like I should be able to get away with just a little hot glue along the sides here to make it nice and easy. Someone asked, oh, Mr. Certainly asked about the handle on my reamer. It's a big, giant blob of sugru. Back in the early days of sugru, I got hold of, I think they made much larger packets back then, and I had an orange one, and I used it all to make this reamer a nice fit. All right, so my friend hot glue. Thank you. So that's all we'll need, I think, to keep that in place. This Seagrover cutting 5-ply with a 2-ply blade. Yeah, I think you're right. Okay, so let's let that cure and cool, and then we'll start thinking about, I'm going to switch cameras over to this guy. So let's start thinking about the, I'm going to place this in here. It's good to do a reality check and start seeing how things are going. So I'm going to place that in like that. Looking good. And it doesn't actually protrude, the little head does not protrude very far. It doesn't protrude as far as the frame, so I can set it down like this and I'm not mushing it, which is nice. All right, so now what do we have to deal with? We've got our Circuit Playground Express, which I kind of want to mount something like this. I want my batteries maybe like that, a speaker. And actually the speaker, I've noticed this little mini metal speaker sounds really nice when it's pressed up against something tight. It has a little bit of buzzing and rattling sometimes, but I'm going to tape it just to the back of this cardboard and it'll give us a nice sound, act like a soundboard sort of. So let's see, with that plugged in there, this plugged in there, that here, we've got some options. So for mounting, I was thinking of using, I've got these little nylon M2.5 standoffs. So I could attach standoffs maybe to the Circuit Playground Express, or the Cricut rather, and then maybe run these through the cardboard or down into it, screw them into it, or maybe just hot glue some standoffs. That might be nice. Let me try it that way. And so let's take, zoom you in here. So these little standoffs, I'm just going to set maybe 4 of them with the little short screws. There's a standoff like that. You know, normally you'd run a hole through and another screw up through whatever you're mounting on, but this cardboard has got the mat on the other side of it, and I don't want to make a space there. So I think just hot gluing those down onto the cardboard is going to be just fine. So let me take 3 more of these. I love little nylon screws and standoffs for this kind of stuff. They're great. So put another one on there. Mr. Certainly said, little speakers like that resonate much nicer when placed against objects. I've noticed the same with the old-fashioned mini music boxes, hand crank ones. Yeah, they lose so much sound when they're taken out of their enclosure. I agree. I think those were meant to be, I think those little mini metal speakers were definitely meant to be used with a tight fit enclosure. Gotta be, right? We got a bunch of cards for my wife's uncle for his birthday that had, a bunch of different people gave him cards that had sort of built-in sound chips and speakers and even motors that were wiggling things. It was great. I kind of wanted to scavenge them and do a teardown. Okay, so I think something like that. And the nice thing here is that I could unscrew the Circuit Playground Express and Cricut from the painting if I needed to. But it's a fairly easy assembly because the hot glue is just going to be on these 4 standoffs. So let's zoom in again and I'll move the painting up like that. So you can see I'm just going to blob hot glue on these 4 standoffs. Let's set them down like so. And there we are. So we'll just let that cool, and we could just unscrew those 4 screws and lift this off if we needed to later. Let's see, for our battery pack, we could kind of do the same thing. Or we could just tape it down, glue it down. I think I'm just going to glue this directly down. Like this. You know, we could end up with a problem with things, the painting not wanting to balance, so it could be that it needs a little bit of a fancier hook and nail and multiple pieces of hanging hardware so that it doesn't just want to flop over. And then for this little speaker, I'm just going to use tape for now, I think. Just a little bit of tape to secure it to the cardboard. Okay, so we'll plug in our servo, plug in our battery. All right, everything seems to work. I don't know why it's doing one right at the beginning. That's weird. It wasn't doing that before. What changed? Mysterious to me. All right, I think everything is dried, glue-wise, or cooled. So now, let me show you, actually, I'm going to switch out to my workshop camera for a second here. Let me hide that side view. I want to show you a quick workshop tip here, which is build yourself a fake wall. If you're doing things where you need to hang things on a wall, your workshop, if it's anything like mine, doesn't really have any open walls because everything's got pegboards and things on it. So I can't remember, you may have seen me use this before, but this is essentially a piece of MDF and a little T-shaped frame that I screwed to it of 2x4s, and it's not beautiful. It's actually, for some reason I can't remember what, I needed another piece over here. But it's just sort of a sloppily screwed together with wood screws. I drilled some pilot holes and took some scrap 2x4, and now I have a wall, so I can paint it. I've hung things from it to make backdrops, like pieces of foam core or fabric. And I think when I was doing my cold brew coffee maker, which was a wall hanging one, I prototyped it on this. So I'm just clamping it. You could screw it down into something. I'm just clamping it into a bench vise here so that it doesn't go anywhere. So you can see here, if I clamp in the cardboard on the painting, I'm not going to, this isn't the permanent solution because it's going to be banging out against the electronics right now on the wall, but I hammered a hook into here earlier, and you can see this will now allow me to test what it means to hang this on the wall as far as pushing it out from here. So that's a little workshop tip for you, is build yourself a fake wall. It's actually pretty useful. So yeah, portable wall. Who figured, right? And it doesn't take much space. I put it out of the way when I'm not using it, but it's just got, you know, this much depth, so you can hide it somewhere if you need to. But it's pretty useful. So okay, so now what let me take a look now at getting this thing a little bit of protection. So you can see we're protruding like 1.5 inches, 2 inches out from here. The highest point is actually my servo motor connection. Let me switch to a bigger view here. Zoom in so you can see there. That's what I've got to protect for. All right, so I had a couple of ideas on how to do this. I haven't done any of them yet, so let's see what's kind of the most expedient one. The one thought I had was some scrap, and I don't have, let's see, here's some, I think 1x3. So we could take some 1x3, cut it, and just make a sort of secondary box kind of frame, and then glue it or drill it or nail it, screw it somehow into here. what I might try to do, let's see. Yeah, I just about left myself enough room to do what I was thinking here, which is run a couple pieces just vertically, and then one across the top. So that's one idea. You could probably also do something with cardboard and mount it just to this piece here. Here's some scraps. So something like this type of shape. If I could bend it well. All right, a couple pieces like that that are high enough to lean against up here and here. And I'm open to ideas, so I'm wondering if anyone in the chat has an idea of how they would go about this. Partly because I don't really want to damage the frame or permanently attach something to this frame, because I may reuse it. So let's see, here's some other cardboard. Maybe we could mount like that. Basically put a box around the whole thing like that. So those were my primary ideas. I think I'm going to go for this, yeah, what the heck. I think I'll cut this wood down to size and just make a little ledge at the bottom, ledge at the top that we can hang it from today. Better would be a full box, but let me try to do a quick and dirty version. So what I'll do is I'm going to mark this, and I'm just going to cut it on the bandsaw. So let's put a little mark here. Oh, this thing's bowed. Huh. Let's get a flat piece. Something like that. All right, so let's see if I can cut that on the bandsaw. Is that too big? All right, I'll have to do it in steps to a couple of them. I don't have my table saw out or a chop saw out. So let me give you the sort of biggish view. Can you see? You can't even see my bandsaw from here, can you? Bandsaw. Here. Yeah, you can. All right. You'll hear it. Let me grab some glasses. Oh, here's some nice scrap too. Kind of like that. That might work. Do a couple small pieces. Let's try this. All right. I think what I'm going to do is cut this in half and set a piece there and a piece there, and maybe reinforce it with a little block. So let's just cut this in half roughly. This can be pretty crude. And I wonder, yeah. All right. Well, this may end up being more permanent than I wanted, but it is possible to do it maybe with hot glue live on air. I don't want to drill into it, and if I use actual wood glue and clamps, it'll never be done by the time we're done here. And we're almost out of time. We're actually kind of out of time, aren't we? Oh, someone's suggesting proto-pasta's wood filament. Okay, so we now have, we'll let that cool and I might try to reinforce the top, but we now have essentially a little buffer zone for the wall, and I'm going to try to hang it from this top one, so I want to place a little support above as well. And if I do need to get these off, we'll test the theory of being able to squirt some rubbing alcohol in there and pop it off. Oh, go to this view here. Oops. There we go. So close. There we are. So I'm going to place another little scrap right at the top there to block that in. Give it some strength, the semblance of it. Certainly there are better ways to do this than what I'm doing right here, but this is just a quick and dirty version, especially if you're using this as like a Halloween prop kind of haunted house sort of thing. Better would be to screw it into that or use proper wood glue. Oh, someone asked about the tennis ball thingy hanging from the ceiling. This is a pipe clamp that I'm hanging a camera from, my overhead camera, that one, you can see a wiggle. And actually on the suggestion of someone in the chat, I think it was Nis, said, you're going to put your eye out on the bottom of that pipe, so you should stick a tennis ball on it, so I did. But I just use it to hang camera or lighting equipment. All right, I think this is, it feels strong enough. It's a pretty light thing, so I'm going to go for it. So let's switch out to that camera, and let's hide this other camera. And I'm going to turn off my loud AC for a second there. And now your main fan noise is just my little fan that's cooling that one camera. Okay, so I think I'm going to hammer a second nail in to give this thing a chance of being straight. Let's see. Oh. And where'd that? Where that size of nail went. There we go. Roughly the same. This won't be perfectly level. But we can bend it to eyeball it. It's pretty level. And presuming my little wood block on the back of that's level as well, let's turn this on. Oh, I think the battery is dying. Okay. Hey! All right, let's swap the... Either get some fresh batteries or, you know what, for now I'll just run a real power to it. One thing you can do with these fake walls is you can just drill holes through them to run power into your paintings and things, but that's not always realistic to how you're going to do the final thing. Depends on your setting. If you're on a stage or a haunted house, for sure. In your own home, maybe not. All right, there we go. Looks good, you can see it. Let's try to yell at it. Ah! Ah! Oh, that was the 2-second buffer where it doesn't listen to you. Ah! I'm very happy about this. Let's see, can I zoom that camera in? Let's see if this remote will let me zoom. Yeah. Oh, that's as far as it'll zoom. Ah! So that is the scream, just as Edvard Munch wanted it, I think. Yes, I'm glad you like it, Matambale. I'm very happy with this. What a weird thing. Yeah, so it doesn't quite pick up like a snap or a clap so consistently, but the yell seems to work really well, and you might be able to, like I say, calibrate that. Ah! Screaming definitely works. So, let's see. Any other stuff from the chat? Good impersonation. All right. I don't feel the existential angst that poor Edvard felt, clearly, because I'm just so overjoyed about the thing being silly. So thank you so much for tuning in today. I know we went a little bit over on time, but I kind of say that every week, don't I? Let's see. I think that's all I've got. I will mention again our 10% off coupon in the Adafruit store this week is Edvard, for our good friend Edvard Munch and his scream over there. And I will be writing this up as a Learn guide, so if you want to make your own, we'll have more details available on learn.adafruit.com. And I think that's all I've got to say. So thank you all so much for stopping by today and hanging out with me on John Park's Workshop, and I will see you next week. Bye-bye.